Yes, thank you. Today we're going to be talking about section 5.15, Aufbau's Principle. It is the same thing that you will see here on your packet, guys, okay? So that's just a quick reminder. So how are buildings constructed? You know, if you've ever seen a building go up or a home go up in your neighborhood or around, down the street, they always lay out that foundation first. Construction of a building always begins at the bottom. The foundation is laid and the building goes up step by step. You obviously cannot start with the roof since if there's going to be no place to hang it, right? If you have not started from the bottom up. The building goes from the lowest level to the highest level in a systematic way. And you have a picture here that you might recognize, right? Anytime a building like this goes up, they lay out the foundation, they build level 1, they build level 2, and then they build the top of the building. And then they fill it in. Okay? So the same thing happens with electrons when we're talking about electron configuration. Okay? And today's topic is Aufbau's principle. In order to create ground state electron configurations for any element. So ground state just means it hasn't absorbed energy, electrons haven't moved, or haven't jumped to a higher energy level. It is necessary to know the way in which the atomic sublevels are organized in order of increasing energy. And you have a figure below that shows you the order of these you have a figure that shows the order of increasing energy of these sublevels. Okay, you have down here 1s, 2s, 2p, 3s, 3p, 4s, and then so on and so on. And you can see the order right here. And here you have the definition of Aufbau's principle. Electrons are added to atomic orbitals in order of from low energy, bottom of the graph, to high energy. Okay, hold on, guys. I'm getting. All right, sorry. Okay, so as we're saying, Aufbau's principle says that electrons are always added to these atomic orbitals that have low energy to high energy, and that's what you see here. Principal energy levels are color-coded, while the sublevels are grouped together, and each circle, you have to always remember, holds 2 electrons, okay? So you have your, it tells you that your energy levels are color-coded. So you have them by color is the energy level for those electrons. And then each circle, again, holds 2 electrons. And the part that always confuses my students is right here. Once you get to 3p, you would think that it would be 3d that comes next. No. These s orbitals that you see here are slightly lower than the other energy levels. So instead of going from 3p to 3d, it's 4s and then 3d and then 4p, 5s, 4d, 5p, 6s, 4f, 5d, and 6p. And we have a diagram, we have a graphic organizer that helps you remember the order of these energy levels, okay? So don't worry if this looks confusing. There is something that we're going to show you later that's going to be a little bit easier to understand as far as which one comes next, okay? All right, according to Aufbau's principle, what order are atomic orbitals in, okay? Is it high to low? Is it low to high? What did we say in the last slide, how these atomic orbitals are organized? How do we fill these electrons? As we're adding electrons, should we start at the highest energy level or at the lowest energy level? Yes, sir. No problem. What do you think? What do you think? Is it A, low to high, or B, high to low? I believe this is a multiple choice question, right, guys? It's a multiple choice question. Just double checking those of you who are in Pear Deck. So A is the order from lowest energy to highest. B, highest energy to lowest. What do you think? What do you think? B, says Irvin. Okay. I got 2 out of 3 students. Let's see their response. Everybody is choosing B. High energy to low energy. Anybody want to pick something different? Anybody want to pick something different? Oh, I got one person who says low to high. All right, let's go back to the slide. Go back. Okay. According to Aufbau Principle, electrons are added to atomic orbitals in order from low energy to high. The answer was A, guys. A. Be careful. Okay, be very, very careful. All right, so the lowest energy sublevel is always the 1s sublevel, which consists of one orbital. If you're talking about a hydrogen atom, you only have one electron that's going to be in that 1s orbital. As we proceed with multiple electrons, right? Every other atom after hydrogen has multiple electrons. Those electrons are going to be added to the next lowest sublevel. So after 1s, 2s, after that, 2p, after that, 3s, and so on and so on. Again, they're restating Aufbau's principle. It says that an electron occupies orbitals in order from lowest energy to highest. And in German, you have to remember that Aufbau means building up, construction, right? If you have Mr. Gamboa's class, you have the construction class, okay? So always think Aufbau, Gamboa, which Mr. Gamboa's class is construction. This principle is sometimes referred as the building up principle, okay? It is worth noting that in reality, atoms are not built by adding protons and electrons one at a time. This method is just a helpful way for us to understand what you're looking at, okay, and where exactly all of those electrons are. That's why I'm failing Gamboa's class. Oh, no. All right, so you got to write in your response. What do you remember Aufbau Principle stating? Okay, what does Aufbau's principle state? So, quick hint. What is the class for Mr. Gamboa? What is Mr. Gamboa's class that Irvin is saying that he's failing? What class is that? Type in your response. Type in your response. What does Aufbau's principle state? Right. It's all about construction, right, Irvin? And if you're talking about constructing and you're building something, do you build from the top up or from the bottom up? Do you start at the top and then build down? Is that the way you do it? How does Gamboa say to do it? It's all about construction, but when you construct something, when you're building it, you always start low to high. Very, very good. Very good, Irvin. You start low and then you go high. Excellent job. Thank you for answering in the Google Meet. Okay, now this is the graphic organizer that makes it easy, okay? That makes that order and how it goes easy. As seen in the figure, the energies of the sublevels and different principal energies eventually begin to overlap. We know that they overlap because we saw the video yesterday that shows the overlapping. After 3P sublevel, it would seem logical that a 3D sublevel should be the next lowest in energy. However, that's not true. The 4S sublevel is a little bit lower than 3D sublevel, thus the 4S fills first. Following the filling of the 3D sublevel is the 4P, then 5S, then 4D, and then note 4F sublevel does not fill until after the 6S sublevel. This figure is useful and simple aid for keeping track of the order to fill these atomic sublevels, okay? So let me show you how this arrow works, okay? You know how on The Wizard of Oz, they tell Dorothy, hey, Dorothy, follow the yellow brick road. Follow the yellow brick road, right? Well, in our case, that yellow brick road is a red arrow. Start at the top of your arrow, follow it down. Then go to the next arrow, follow it down. Then the next, and then the next, okay? So this is what you have here. This is our yellow brick road, okay? Except our yellow brick road is a red arrow, right? So you start at the top of your arrow and you go down. Then you go to the top of the second arrow and then you go down. And then you go to the third arrow, down. Fourth arrow, down. And then so on and so on and so on. So if I were to ask you, Irvin or Oscar or Caitlin, anybody, if we have 1S, what comes after 1S? So you are at the bottom of the first arrow. Are you going to go to the bottom of the second arrow and then go up, or are you going to go to the top and go down? What would come after 1S? Anybody listening? If you are starting at 1S, what comes after 1S? 2S. Everybody see that? What comes after 1S? Okay, well, I started at the top. I went down through 1S. I'm at the bottom of this arrow. I'm going to have to go to the top of the next arrow to see what comes after. So what comes after? 2S. Okay, so then I go 1S. Then 2S. Okay, so now at the bottom of the second arrow, I'm going to go to the top of the next arrow. Right? And what does it lead me to? 2P. What comes after 2P, Irvin? Follow the arrow down. What comes after 2P? 3S. Okay. I'm at the bottom of the third arrow. I'm going to go to the top of the fourth arrow. What comes after 3S? And then after 3P, 4S. And then again, and then you keep going, and then you keep going, okay? Some people like this one. Other students like this one, okay? And you can see it on Google Meet. It's not on Pear Deck. It connects all the arrows, okay? You start on top of the green arrow, you go down, you follow what's in blue, then you go down, you follow blue, you go down, blue, down, blue, down. Some people think it's easier when they connect because all you have to do is just follow the arrows. We don't have that in our presentation. We have just diagonal arrows, okay? But just remember, when you get to the bottom of one arrow, go to the top of the next one, and then the top of the next one, and down, and top of the next one, and down. Okay? You never go backwards. Question here. Try this one. Which orbital is filled after 2p? Find your 2p and then go down the arrow. What comes after 2p? Write in your response. Type it in. Type it in. Oscar, are you there? Yeah, Alexia. Oh, she got kicked out or what? I don't see her. Oh, no, you're right there. Very good, Irvin. Irvin is saying that after 2p, which is right here in this third arrow, he's going to go down to 3s. All right. Let's see what everybody else wrote. Excellent. Excellent. Okay. Let's watch this video. If you have your packet, turn to the periodic table at the beginning. Get 4 colored markers, 4 colored crayons, 4 different colored highlighters. Okay. And I want you to follow what she's doing on your periodic table. Okay. And you should have a periodic table at the beginning of this packet. So do some flipping, go to the beginning, find that periodic table, pull it out, or just leave it there if it's stapled, and do what the teacher is going to tell you to do in this video.
What I'm going to go over in this vodcast is how we got all those labels on our periodic table. In electron configurations, there's this rule called the Aufbau Principle, and the Aufbau Principle says that electrons like to fill low energy first and high energy last. So when we talk about filling low energy first, we're talking about the first energy level, the second energy level, the third energy level. But the problem is, once we get into the third energy level, orbitals start to overlap, and the order can get a little confusing. By putting labels on our periodic table, it can tell us exactly which order to follow so we know what to do when we're doing our configurations. So the first thing that you want to do is on your periodic table, I would like you to pencil in a helium right here. So we're going to draw helium in there. We're not going to erase it on the other side, but we want to pencil it in there because we're going to count helium as part of this second group on our periodic table for the time being. And then the next thing you want to do is make sure that you have the energy levels labeled. On your periodic table, these numbers are most likely already there. My periodic table is going to look slightly different than yours. But the energy levels would be 1, 2, 3, 4, 5, 6, and 7. Those would be the energy levels. The next thing I would like you to do is block off the sublevels. So the first thing we'll do is we're going to draw a box around the S sublevel. So if you grab those first 2 columns, and you can take some Sharpie markers if you have some, or any kind of highlighter that'll work on your periodic table, and block that off and label that as the S sublevel. All the elements in this block are in the S sublevel. And then if you want to, you can switch colors and come over here. And we're going to label the S block. So we're going to go right along here, excluding helium. Down the side, grab those guys on the bottom row. And we're going to label that as the P block. And then if you want to switch colors again, you can label the D block, which would be in the middle. And then the F block would be the elements down at the bottom here. So pause the vodcast for a minute and go ahead and make sure you have those labels on your periodic table before we move on.
All right. So the reason why she put helium over here is because it is part of that S block. Okay. And I would use different colors. It's just easier to keep track of the different orbitals if you use different markers, okay? Or crayons or whatever it is.
All right, now that you've done that, what we'll look at is the order in which the electrons fill these orbitals. The first place that electrons are going to go is into the 1s sublevel. We call this the 1s because it's the first energy level, S sublevel. The second place electrons are going to go is into the 2s, second energy level, S sublevel. If you then come across the periodic table, the next group that you run into would be called 2p. 2p because this is the second energy level and the P sublevel. So we have 1s, 2s, then we come across 2p. You read this just like you would a page in a book, left to right down the page. Then the electrons would go into the 3s and the 3p. Again, this is called 3p because third energy level, p sublevel. Now you would expect 3d to come next. However, this is where the overlap occurs, where the 4s is actually lower energy than the 3d. So we would call this group the 4s, but then right here we would want to label this group as the 3D row. So if you stick that label on your periodic table, that'll help remind you that this row is called the 3Ds. Then we have the 4Ps. In the next row, we would start with 5s. Again, fifth energy level, S sublevel. So this would be the 5s. This group would be called the 4Ds. This is still the 5Ps. The only place that it's offset is here in the middle. The sides are still the same. Then we would come down to the 6s. You would expect the 5D to come next. However, if you look at the atomic numbers, 55, 56, 57, 58, 59, 60, you realize we got to jump down here first before we do the 5Ds. So after the 6s, we would label this section as the 4fs. Okay, all the way down the line, then look, 69, 70, 71. Number 72 is back up here, so we're going to label this group the 5Ds. Then we have the 6Ps, 7s, and then 87, 88, 89, 90. So we're going to come down here and label this group the 5Fs, 100, 101, 102, 103. 104 is right here. These would be called the 6Ds, and then the 7Ps. So the order that we follow for electrons to fill orbitals is just across and down the periodic table. So we do 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, then we come down to 4fs, 5d, 6p, and then the last row, 7s, 5f, 6d, and 7p. You really don't have to stress over the order too much down here when we get to period 6 and 7 in the F block down here, because those elements don't undergo the chemistry that we're going to study anyway. Those are all radioactive. So most of our focus is going to be kind of from here on up in the periodic table as we go through this. So what you want to do at this point is make sure you have all of these labels on the periodic table, and then check in with the next podcast. And
all right, so you always have to remember these energy levels go all the way across. The only time that it's going to switch is the fourth energy level. So fourth energy level starts off with that 4s energy level, and then it drops back into the 3D orbital. But once you get here, this part over here, remember, these energy levels continue. So this is still 2p, this is 3p, this is 4p, right here is 5p, 6p, and then 7p, okay? The only area that it's going to drop down into a different orbital or energy level, is the D orbital or the D block and the F block, okay? Other than that, you will be using these energy levels, okay? So just be careful when you get to that area. I usually use,
and that'll give you
the, let me exit out. I usually give my students this one. It's already labeled. It already has the number of electrons in the corner. It starts at 4s, 3d, and then 4p. My students in the past love using this periodic table rather than making their own, because all the information they need for the energy level, the type of orbital, and even how many electrons. This one is the most useful. The one that my students find the most useful and easiest to follow. Okay, because all I do is I tell them cover everything up to 1s, pull it down, and keep writing what the boxes say until you get to the element that you're looking for. Okay, so if you're looking for the electron configuration for phosphorus, you start at 1s. Well, what's the maximum? 2. Then 2s, 2. 2p, 6. 3s, 2. And then they stop at phosphorus, which is right here at 3p3. Okay, my students just find it easier to use this electron configuration periodic table than anything else. They find it easier than doing the diagram that they showed you, which is, they find it easier to not use this one, okay? Because everything you need, it tells you the electrons, it tells you the energy levels, and it tells you the orbitals. All right, let's finish up your pair deck. In summary, the Aufbau principle gives the order of electron filling in an atom. It could be used to describe the location, the energy level of every single electron for a given atom or element. Review questions, very simple review questions. Number 1, what is Aufbau's principle? 2, which orbital is filled after 2p? 3, which orbital is filled after 4s? 4, which orbital is filled after 6s?